Okay, so you presented at the Data Center World not too long ago, and I think the focus was on protecting the planet with liquid cooling technology. And I guess before we get into that topic, it'd just be good to understand how the event went for yourselves.
It was very good. It was another very busy event this year. It seems to just get a little bit busier year on year, and SWEP have been at Data Center World. I think this would be our fourth year now, and we've seen gradually the kind of liquid cooling trend, gathering momentum. So we're seeing more and more people displaying products relating to liquid cooling and how that market's developing. So things like coolant distribution units were featuring a lot more. So a lot of companies that we know that historically have worked with air cooling are now presenting more products for liquid cooling as well. And then also some interesting kind of innovations, if you will. So different ways of cooling with liquid, for example, using ammonia direct to chip. So you can really see it. I mean, the talk's always there and the feeling in the market that it's going to liquid cooling, but it's visible, it's evident at Data Center World. So that for us is important to be a part of, to see that development really happening on the floor, if you will.
Yeah, and in terms of what you were talking about, I think if memory says you started with obviously a bit of background on yourselves and the Brazed Plate Heat Exchanger BPHE technology. So perhaps that would be good place to start here if you can give us.
Yeah. Absolutely. So, I mean, we are a component supplier in the wider cooling system for data centers and other applications as well. So we like to give people an introduction to us as a company, but mainly the products that we make as well, because it's not obviously evident that this might be used in data center cooling. There's no electronics, there's no pumps or anything. So just explaining, first of all, how the heat exchanger works, what is a heat exchanger? And then we start to show people the different areas of data center cooling, where it might be used. For example, in the refrigeration system, the chiller sat outside the building, and then we've got the coolant distribution unit placed within the building as well. Sometimes there's another hydraulic brake, which is separating the two bodies of water. So it's just showing what the product is that we make and where it sits in the data center and why we're there talking about it at the time, really. So just to give them some context, because we see so many different parts of the picture, it's quite nice for us to explain that a little bit more.
Yeah, and I guess no secret, the AI explosion is adding to what were already fairly substantial pressures on data center cooling, and I think, well, sorry, I don't think I know, obviously, that air and liquid are now being looked at. Air traditionally cope with most, if not all, workloads, now liquid. So just, I guess it'd be good to have your thoughts as to just, how much the pressure has gone up in terms of what data center cooling is expected to do, and hence why air and liquid are being looked at, comparisons, etc., between the two, if you like.
Oh, absolutely. I mean, from what we can see, we're relative newcomers, I think, to the industry of data center cooling. But our observation is that the historic method of doing it with air has worked quite well. And when you read into the reasons behind that, the chip manufacturers have managed to keep a lid on the temperatures generated by their server racks, just with some clever innovations, but I think they've reached the limit of stopping that, and so now the temperatures are climbing. Air's becoming much more tricky to cope with that. So they're talking about, we can still do it with air, but we're having to ramp up the fan speeds enormously. There's not a lot of resilience if the system isn't designed particularly well. And then you get issues that you might not imagine, like the noise. Can you imagine the noise in an air-cooled data center that's got these extremely high winds, if you will, blowing through it? So anybody working in there, it becomes difficult. So it's really, I think the tipping point would be the best word to describe it, where they're now saying, hey guys, we've got to look at other ways of doing it. And of course, liquid is the most obvious choice. Certain chip manufacturers, are actually requesting that their particularly new product ranges are cooled with water. So there's a definite drive towards liquid cooling. I think that's clear for anyone to see. And the challenge is how that will actually look. You know, what will be the kind of predominant technology that's used, and that's a little bit anybody's guess at the moment. But we have some indications where it's going. You know, cold plate technology, even hybrid systems, or what might be called hybrid, like a rear door heat exchanger. We saw a lot more of those products at the show this year, which is kind of like a bit of a hybrid system. So yeah, but the trend's clear. It's definitely liquid cooling moving more and more. But I think data centers, depending upon the type, may not be 100% liquid cooled. It will depend on the applications, and there might be sections that are fully liquid. There might be some still traditionally done with air, or some hybrid system, depending on the workload. And yeah, this is the real challenge for the developers, to make sure they're kind of future ready for their data center buildings.
Yeah, and in terms of the liquid cooling options, I mean, I think you sort of referenced a couple there. I think so, as I understand it, you've got the rear door heat exchange sort of method, if you like, direct to chip, and then immersion technologies.
Yes.
Do you have any sort of, is it very much sort of horses for courses, or is as you say, will there be an eventual winner? Just your thoughts, I suppose, as to these different flavors of liquid cooling, if you like.
Yeah, I think, looking at the way the products were being exhibited, and where a lot of manufacturers are going, I think direct to chip technology and rear door will probably be the mainstream solution for liquid cooling. Immersion cooling on paper is by far the best way of doing it, in terms of the ability for it to get rid of heat. But then you've got the challenges of quite large amounts of the cooling fluid, which is dielectric. You know, it's non-conductive, and there's concerns about that at various levels. So you've got the kind of chemical concern. You know, what are these fluids containing? PFAS is quite a hot topic at the moment. So these forever chemicals, they call them. So some of these refrigerants and liquids that are being used for single and two-phase immersion, there's uncertainty about, maybe not today they're going to be restricted, but will they be restricted in the future? So again, it's back to that future-proofing thing with immersion cooling. So yeah, I think definitely cold plate and rear door heat exchanger will be the predominant technology. And I think even if traditional air cooling could be used, I think they will still move to something like rear door, because it's just a more efficient way of doing it. So, you know, I think that'll be the way that we'll see future data centers, less of the hot and cold aisle, systems that we're seeing at the moment.
Yeah, and I guess the other thing that's being talked about in relation to liquid cooling is the opportunity for heat recovery.
Yes.
And I think, again, if I remember correctly, you shared an example, I think, that you were involved with the eco data center. So I don't know, you perhaps just want to talk a little bit about heat recovery. Clearly, it depends, I think, where the data centers are located as to how practical. But just talk us through a little bit about heat recovery, and if you want to share the eco data center example, great. So.
Yeah, absolutely. So I mean, heat recovery is another hot topic, and it almost aligns us or connects us with another industry that we're a lot more familiar with, which is district energy. So this would be the typical consumer of waste heat, and ideally the data center is located next to a network. But broadly speaking, there's kind of two ways we can recover heat from a data center. We can take it directly from the liquid, the water that's cooling the server racks, be that direct to chip or rear door heat exchanger. And so as that warm water is coming back from the server racks, we're basically intercepting that with a heat exchanger and sending it off somewhere, ideally, again, district energy. So using the liquid itself is probably the most easy and obvious choice. But then we also have the ability, if the data center is cooled with what we call mechanical cooling or refrigerant-based chiller systems, we can intercept the refrigerant gas. So the hot refrigerant gas can be kind of captured, if you will, and then that can be used also for water heating. In the case of eco data center, it's quite a novel approach, actually, what they've done. So they've used the refrigerant heat recovery concept, but there wasn't anywhere locally that they could send that to easily in terms of direct heat consumers. So what they've actually done is sent it to a nearby wood pellet production facility. And so this waste heat, it's not particularly high temperatures, is being used to dry the pellets that are then burnt in a biomass plant for district energy. So in a way, it's indirectly going to the district energy network, but not directly through the liquid, just through some different steps. But absolutely, the big challenge is connecting the place that has waste heat, the data center, to the consumer of waste heat, be that local swimming pool, district energy, commercial building of some kind. And this is a difficult one to address. If you've got an existing data center, it's not so easy to have an infrastructure of pipes running nearby. This is a major infrastructure project that needs to be undertaken. Who's going to pay for that? But then we start to see these ideas, concepts, if you will, that future data center developments will have, houses and commercial buildings and other facilities built around them. And so you're almost thinking of a data center like a power plant, like a heat generator, if you will. So this I think is quite interesting. Obviously, it's applying only to new developments, but yeah, I could see that being quite a thing that takes off if the site's obviously in the right location for these sorts of buildings to be built around it. You then got the commercials as well. So there's a lot of talk about how that would work. The kind of, do the data center operators want to be paid for this waste heat? I mean, I've heard guys in talks saying, you know what, we're absolutely happy to get rid of it, but they don't want the responsibility of being kind of heat providers. They just want to get on with their business of running a data center. So it's one of the many things in life, it's wonderful in theory and you can see it all working, but then you've got all these nuances and things that need to be ironed out to make it work. But I think with regulation now driving more heat reuse, we will see more of it in the future, which is good to see.
Okay, and in terms of yourself, SWEP, it'd just be good to understand how your technology, what role your technology plays in this sort of data center landscape we've been discussing. And I guess obviously all the data center owner operators are looking for more efficient cooling solutions. And as I think you alluded to earlier, the likelihood, obviously, if you built yourself a sort of AI factory, if you like, it may be liquid only, but the chances are you're going to end up with some kind of hybrid solutions. You've got air and liquid cooling. So just, where is it that your cells fit into this sort of evolving landscape, if you like?
Yeah, so I mean, what we see is quite a demand now for our products to be used when we're transferring heat from one fluid to another. We don't lose any energy, but we have to step down the temperature from the inlet to the outlet. So we can't get perfect temperature transfer. So we see a demand for this, and we can get very close. But what happens is, if the closer we get to the inlet and outlet temperatures being the same, we need a much bigger heat exchanger for the same given duty. So we're seeing a lot of demand for these very tight temperature profiles, which means we need a bigger heat exchanger. So we're having to really look at the product range more closely. We're trying to optimize more designs. This is more on the kind of water-to-water liquid cooling side. And then we get things like the immersion cooling guys that are concerned, for example, about the fluid in their dielectric tank or two-phase immersion, which is non-conductive. If we've got water on the other side, plain water, if the heat exchanger fails, we've got mixing of the two fluids, and we're going to ruin quite an expensive lot of equipment. So fortunately, we have products that mitigate that already, but then we've got the chemical compatibility of these different fluids that are being used, different product sizes, even, something as small as that, because they have existing server cabinets that they need to fit everything into. And then even down to other small details like the type of connections that they use. Some of the ones are not so familiar to us in our more traditional industries. So, for example, a lot of the guys in data center cooling with coolant distribution units are using what they call tri-clamp connections, which is quite quick and easy to dismantle. It's quite secure. They're used in hygienic industries like pharmaceuticals and so on, and food production. So yeah, it brings it's quite a few unique set of challenges for us where we're having to look at product design, optimize our design software to make sure it's providing the right solution for people at competitive commercial cost and physical size and so on. So yeah, it's a unique set of challenges that we're adapting to quite well. We're looking to develop some new products specifically for data centers, and then we get things like the capacities with coolant distribution units. They're looking now at 1 megawatt capacity in a single unit. So this is quite tough job for a heat exchanger, and we do have solutions there that will fit. But then again, it's about size, position, connection. So yeah, it's been quite a fun time trying to adapt to all these little ways that present themselves.
Yeah, and maybe just sort of in finishing, it'd be good to understand, I suppose, how you see, clearly in the world we're living in, predicting what's going to happen in an hour's time, let alone
Yes.
whatever it is,
Yeah,
quite challenging.
Yeah.
But it'd be good to have your thoughts as far as you're happy to share in terms of how you see the data center industry, and the cooling sort of ecosystem developing with this sort of AI pressure, I guess, and also how yourselves, I'm sure you're not going to tell me sort of too many secrets, but just your sort of direction of travel, if you like, with to respond to those challenges, opportunities.
Yeah,
the industry develops. Would be good to understand.
Yeah, definitely. So, I mean, I think in terms of where the industry is going, absolutely liquid cooling. I've heard so many talks where chip manufacturers and developers are really saying, look, this is where we need to go. So liquid cooling definitely is the way forward. The question is, how exactly will that look? Will it be 50-50 rear door and cold chip? Will it be, 90% rear door and 10% cold chip? That's not so easy to say at the moment. I think with immersion cooling, that does seem to be more for the very niche applications where we really, really need to have the best cooling solution possible. So things that I hear of, or examples are Bitcoin mining, things like that. So yeah, and then you've got, you chuck that into the mix. You've got things like, well, what if the chip manufacturers find clever ways, some novel solution to have chips running, much cooler than they are doing at the moment, based on the current trends. So it's really hard to predict. I mean, I would say confidently that it will go liquid cooling, but I mean, who knows if there's some development that comes along the line that allows chips to run cooler, then they can stick with the air system because liquid cooling, it is great, it's very effective, but it also has a lot of challenges. It's adding, I think, quite some cost, initial capital outlay. It is cheaper to run. So yeah, it's not so easy to predict, but right now the feeling from our side is liquid cooling, rear door, cold chip as the mainstay, immersion as a kind of niche application. And then, yeah, I think the rise of AI is also quite, clear that's really going to take over. I don't know to what level, but I'm seeing more and more just in everyday work. You probably do yourself, Phil, with things like PowerPoint and Excel and all these other applications we use every day. They're having AI built in as a kind of little assistant, and then even some websites now have got AI chat. So I think we'll see that more and more at our everyday level. Hard to really know where it will go at a kind of higher level, with professional, let's say, medical use and so on. But I think it's definitely here to stay, and we'll move forward. But, liquid cooling is more efficient generally, and I think the drive towards having more efficient cooling systems, heating systems in houses and so on, if all these other factors don't quite work out, like the rise of AI and chip temperatures, I think liquid cooling is a good idea anyway. So that gives me a little bit confidence to say that that's the way it's going to go. And for us, it's just trying to stay nimble. It's such a fast-moving market. We try to adapt as quickly as possible. And develop products that are suitable, different sizes, different connections, and so on. And really, the most important thing is just to keep close to the action, to what's going on, and try to understand the challenges. And then it's an interesting market to be involved with as well. So yeah, we look forward to seeing how this develops in the next few years.
Yeah, and I mean, just as interesting, do you have a sort of, as far as you can, a sort of firm roadmap of what you're looking to introduce over what time? Or as you said there, are you very much flexible? You'll kind of respond to the trends that you see, or is it a bit of a mixture? So you sort of have an
Yeah,
idea of where you want to be, but you also are aware that, oh, okay, we need to slightly change that because this has happened, etc. Just yeah.
I think it's adapting the product range with accessories, things like connections that are desired, and being able to put them in certain places on the heat exchanger. But also, our products are typically they might be used in more demanding applications in terms of, let's say, the pressures and the temperatures that we need to operate at. So we might have to look more closely at maybe having versions that are not so rated to such high pressures, which obviously adds some cost to the product. So maybe, if you will, value engineering suitable for a data center application with fairly low temperatures, fairly low pressures. Of course, it still needs to perform, but do we need something that could normally be used in a high-rise building with 20, 30 bar pressure? Probably not for a data center. So trying to adapt the product range, because of course everything, cost is always an issue in any development. So trying to make sure that we're competitive in the market. But then on the other hand, we've got the quality aspect. The data center operators, of course, they're looking at the numbers, the capital outlay, but they're very strict about the performance. So they want to see things like third-party verification. So it's good enough, it's not good enough for them, or they see our design software and the prediction it makes in terms of performance, but they want someone else to verify that. And so that might not always be done on an ad hoc basis. So we already have AHRI certification, which is the American Heating and Refrigeration Institute. So they take a range of our products, they test them against given conditions, and basically the criteria is that it must perform as we predicted within a very low tolerance. And so we have quite a range there, but then using them with different fluids. So it's quite the whole picture of how we develop the product, rather than just the sheets of metal, the whole side around it, because they need resilience, they need to make sure it's cooling effectively, that it's robust, that it's not going to fail. So I would say the quality criteria compared to a more traditional industry we might work in, such as building services, high-rise apartments in London, the quality aspect is a little bit higher with the data center guys. So that's another focus area for us.
Okay, so it sounds like it's an exciting opportunity for yourselves, and you're looking forward to where it might take you. But it's a bit of a, I won't say seat of the pants, but there is a
So
certain amount of uncertainty. But as I said, bearing in mind what's going on elsewhere, that's almost becoming the new normal, I suppose.
yeah, absolutely. It's actually quite a fun industry to be involved with. I find it personally interesting. I know a lot of my colleagues do as well. It's a little bit new for SWEP because it's moving so fast. So there is that element of excitement, and we talk a lot internally about the developments that are going on in the different regions. So we're trying to share as much knowledge as we can, just to make sure that we're on top of things, that we're reacting in the right way. Maybe it's not always quick enough because things move so fast, but yeah, it's really an industry that we're having to keep close eye on to stay ahead of things, or keep on top of things at least.
Okay, it's been great to chat, and some fascinating insights you shared about your own thoughts and the company's progress in the data center industry. So be good to touch base with you maybe later in the year and see what else has changed. But at least for now, Adam, really appreciate your time. So thanks.
Yeah, really nice talking to you, Phil. Yeah, it's been good to share the insights, and yeah, good talking to you too. Yeah.